factor today. And like I said, factoring, if you're going to let me teach you guys anything in the entire year of Algebra 2, please let me teach you how to factor. It is such an important skill that's never going to go away. We're going to use it for the rest of the school year. You're going to see it in next year's math class if you go on. This will be on a placement test for any college math test that you are ever asked to take. So please, please let me teach you how to factor. Now, with that being said, let me just say first that when it comes to teaching students how to factor, guys, I can think of probably 5 different ways to teach you guys this. The way I choose to teach you is by a method called guessing and checking. The reason that I choose to teach it this way and not a different way is because I have found that in the 16 years I have been teaching, that when I teach it this way, this is how students remember it months and months to come. If I start teaching you another way where there's all these little tricks and hints involved, 2 months from now, I always find students are like, oh man, what did she say I should do? What was that trick? What was that hint? And they forget because they rely on the tricks. But if I just teach you straight up what every single number's job is and how to factor, I find that students tend to remember this. So some of you are going to pick this right up and remember it from Algebra 1. Some of you are going to be like, oh, I feel like I kind of remember this, but I'm a little rusty. And some of you might struggle for a couple days. I just ask that you give yourself a little bit of patience to get this down. Because again, you may have been taught a different way. You may go on Google later and say, how do I factor? And Google teaches you a different way. This is how I truly believe you should be factoring because I feel like you will remember it later. So again, just try to give yourself some time to get this down. I'm trying to keep it pretty basic and only kind of add one new thing each day so we can take it kind of slow. Because eventually, we're going to want to use this factoring skill to solve a quadratic equation. Right now, I'm just showing you guys how to factor. We're not actually solving a quadratic using it yet. We're just trying to get the factoring down, okay? So please give yourself some time to kind of get this method good. All right, here we go. So just to refresh your memory, we are going to be factoring normal looking quadratic expressions. So guys, a quadratic expression should normally look like this. ax squared plus bx plus c, right? It's got 3 terms. You got an x squared term, an x term, and a just number. That's the ones that we're going to be looking at today. Thank you. No problem, Christina. All right. So the method that I'm teaching you is how to factor these normal looking quadratics. Now, every now and again, maybe we have to do something to the expression first to get it to look like that, and that's fine, okay? That's all part of the process. All right, and then eventually, guys, we're going to be taking this quadratic expression, setting it equal to 0 so that we can solve the quadratic equation by factoring, all right? All right, and then don't forget, when they tell you to factor something, what are they asking you to do? They're asking you to break it up into pieces that multiply. Okay. So now the way I teach you how to factor is literally like undoing a FOIL. We use what we know about FOIL to help us break this expression apart back into its factors. All right, so just to review foiling real quick, we did that on Monday. If I gave you 2 pieces to multiply together, right? Foiling would do x times x is x squared, x times 5 is 5x, 4 times x is 4x, and 4 times 5 is 20, right? And then normally it's those 2 middle terms that are common. So we add those together and you end up with x squared plus 9x plus 20. Well, today, guys, they're going to give you this. They're going to give you the quadratic expression, and your job will be to break it back up into the 2 pieces that multiplied to equal it. So it's basically we're going to be working backwards. Now we know the answer to the FOIL. Can we find the 2 pieces that we had to FOIL together? So the way I think of it as to undo the FOIL, look at what we know from the FOILing. We know that when we FOIL, whatever is in the first spot of this parenthesis and the first spot of the next parenthesis, that always multiplies to get me the first spot of my answer. It always does. Every time you FOIL, this and this always end up as the first part of your answer. And whatever number you put here and whatever number you put there, they always multiply to the last number of my answer. It always works. These last two numbers always multiply to the last spot of my answer. And then, bear with me, I call them my rainbows. It's the rainbows that end up getting you that middle term. 4 times x, 4x, x times 5, the 5x. It's those two common terms that add up to the middle term. So that's how I'm going to teach you to factor. I'm going to teach you to break this up using this piece has to get you the first two pieces. This number has to get you the last two numbers, and then your rainbows have to get you that middle term. And that's how we're going to break this down, okay? Same thing over here. Look at this foil. 2x times x is 2x squared. 2x times 8 is 16. 3 times x is 3x. 3 times 8 is 24. And then we would combine those two middle terms. And that would be our answer. So today, they're going to give us this expression. Our job will be to break it back up into these two factors. Look at what we know. The first spot and the first spot, they got me that 2x squared again. All right, the last number and the last number got me that 24. And then it's those rainbows, I call them, because it looks like an upside down rainbow to me. The rainbows, the 3 times x, the 3x, and the 2x times 8, the 16x, they're the ones that got me the 19x's in the middle. So that's how I'm going to teach you to factor. I'm going to teach you to break down that FOIL. And again, it's called guessing and checking because you're going to have to guess and check a couple different numbers to see who works. But everything has a job. The first two pieces have to get you the first piece. The last two numbers have to get you the last number. Your rainbows have to get you that middle. Everything has a job, okay? All right, so let's give it a roll. Let's see if we can do this. And again, maybe your Algebra 1 teacher taught you a fun trick or a fun adding and multiplying game. I don't do that. I literally just make every number have a job. And that way everybody can remember what everything is supposed to do. All right, so here we go. So guys, our job is to factor the following expressions completely. So we see the word factor. We know we are breaking things up into pieces that multiply. The word completely is important. It means you don't want to leave any common factors in any of your answers. So that means a GCF is going to be really important to us. We're always going to want to look for greatest common factors to take out first to make these numbers and variables smaller and easier to work with. And then we can start breaking it up into the two pieces and the two pieces, all right? Little bit of a spoiler, I'm not going to do any with a GCF today, just to kind of keep it basic, let you guys kind of get the method down, but we're always going to be on the lookout for them, okay? All right, here we go. So guys, if we're going to factor this quadratic expression into two pieces that multiply to equal it, well, first things first, we want to get in the habit, look for a GCF. Does an x squared, a 9x, and a 20 have anything in common? What's the biggest number that divides evenly into them all? There isn't one is it. And then they don't all have a variable, so there's no GCF. So if there's no GCF, that means we're ready to break it up into two pieces that multiply to equal it. So give yourself your two factors. What times what gets me this? Okay, well, according to FOIL, we know whatever I put here in the first spot and whatever I put here in the first spot has to multiply to the x squared. We know that from FOIL. First and first get me the first term. So guys, what do you know will multiply to an x squared? I feel like we have two options. We have x squared times 1. Don't write that down. All right, but here's the problem with an x squared times 1. Yes, an x squared times a 1 will get me an x squared. But an x squared will not help my rainbows get that just x that we need in the middle. So it can't be that. So the only other thing that I can think of that will multiply to x squared and allow me to get that x in the middle is an x and an x. So we're always going to use an x and an x to get us x squared. Okay, well guys, the only thing we're missing now is the number that I need to put here and the number that I need to put here. And we know according to FOIL, whatever number I put here and whatever number I put here always multiply to the last number, positive 20. So we're only allowed to put numbers here and here that multiply to 20. Well, guys, give yourself some options. Who do you know multiplies to 20? 1 and 20, 2 and 10, 4 and 5. All right, I think those are the only whole numbers. Those are the only numbers that you're allowed to put in those two spots. And then depending on which ones you pick, you need your rainbows to get you those 9 X's in the middle. Well, guys, pick your favorite. I'm going to go with the 4 and the 5 because I already can see the kind of 9 that I need. So I'm going to put a 4 here and a 5 there. Now remember, it's got to multiply to a positive. The only way I'm getting these numbers to multiply to a positive is if they have the same signs. Positive, positive, or negative, negative. So if I need them to multiply to a positive and still add up to a positive, I know everything has to be positive. So now check your rainbows. Multiply. 4 times x, 4x. X times 5 is 5x. Can 4x's and 5x's add up to that 9x in the middle? Totally. So we know these are our winners. So now what signs do I need to make 4 and 5 multiply to a positive 20 and add up to a positive 9? I need a positive 4x and a positive 5x, which means he needs a positive sign and he needs a positive sign. And those should be the factors. Now, some of you are going to be like, oh, I remember this. This is so easy. It's fine. I hope it is easy. Now, I think 10 seconds is the best 10 seconds that you can spend is checking your answers. Make sure that x times x gets you the x squared. Positive 4 times positive 5 gets you the positive 20. Positive 4x and positive 5x add up to the positive 9x's. Because guys, some of these problems are tricky and it's going to look like you have the answer, but your signs are off. Or maybe your numbers really don't do what you think they do. So take those 10 seconds and double check that everything is doing their job, okay? All right, give me a thumbs up if that felt okay. Everybody okay? All right, here we go, guys. Let's do it again. So you look here, right? We have to factor it completely. First, we look for a GCF. We always look for GCFs first. Does an x squared, a 7x, and a 10 have a number and a variable in common? No, they don't. So the minute we know there's no GCF, we know we're ready to factor it. We're ready to break it up into two factors that multiply to equal that expression. All right, according to FOIL, I know whatever I put here and here in the first two spots got to get me the first part of my answer, x squared. And who did we say is always going to get us an x squared? An x and an x. So I need a 1x and a 1x to get me that x squared up in front. Okay, then FOIL tells us that whatever I put in the last two spots, they have to multiply to this last number right there, positive 10. So I am only allowed to put numbers here and here that multiply to positive 10. And then it's my rainbows that I'm going to need to get me that 7x in the middle. So guys, what numbers could I put here? Give yourself some options. Who do you know multiplies to 10? 1 and 10, 2 and 5. Now, if I'm going for 7, 2 and 5 are like flashing at me like, oh, those are going to work. So let's try them first. So let's put a 2 and a 5. Now guys, because there's an x and an x, it should not matter if the 2 or the 5 goes first. It doesn't matter. If somebody put a 5 there and a 2 there, we're all going to be fine because each of these has an x and an x. All right? All right, so now let's see what our rainbows are going to do. 2 times x is 2x. X times 5 is 5x. Could 2x's and 5x's get you those 7x's in the middle? Yeah, but let's make sure our signs can work. If I'm going to multiply to a positive 10, I know these signs have to be positive, positive, or negative, negative to get me a positive 10. Well, the only way they're going to add up to a positive and multiply to a positive is if they're both positive. So I know I need both positive signs. So that means he needs a positive sign and he needs a positive sign. Okay, let's double check that everything's doing their job. Does x times x get you the x squared? Yes. Does positive 2 times positive 5 get you the positive 10 at the end? Yes. And then do your rainbows get you those 7x's in the middle? Positive 2x, positive 5x, they add up to my positive 7x's. We're good. Those are your factors. How are we feeling? Okay, everybody good? Okay. All right, now, I want to do this one right away because they're not always going to be as easy as XX, XX. I want to show you one that maybe we're going to work just a smidge harder for, okay? Okay, so guys, look at this one. We have to factor this quadratic expression. It's normal looking, right? X squared, X, just number term. We always look for a GCF first. And guys, especially when I see a number in front of the x squared, I almost get mad. I'm like, I'm mad now. I wish it was just x squared, so I know it's XX. So when I see a number in front, I always think, oh, I hope there's a GCF to make this easier to work with. All right, so we're always looking for greatest common factors. Does a 5x squared, a 22x, and an 8 have a common factor? Unfortunately, they don't. The biggest number that divides evenly into all of them is 1, and 1 doesn't really count, and they don't all have a variable. So there's no GCF, which means if there's no GCF, then we are ready to factor this just the way it looks. We are ready to break it up into two pieces that multiply to equal it. Okay, well, according to FOIL, I know whatever I put here and here in the first two spots, they have to get me that 5x squared. Well, guys, we've already agreed that we're going to use x and x to get an x squared. But now, what do I need to get the 5? What are the only two whole numbers that multiply to a 5? 5 and 1. So that means I'm going to need a 5x and a 1x. Since it's not just xx, the 5 in front here, it just means that now it is going to matter where you put these numbers. When it's just x and x, the 2 and the 5, guys, it don't matter. You could put plus 5 here and plus 2 there. Everything still works out. But the minute you put a 5 with one of your x's and not the other, then it is going to matter where those two numbers go. And that's just going to be part of this guessing and checking process, okay? All right, here we go. I know whatever number I put here and whatever number I put here, it's got to multiply to that positive 8, right? And again, to multiply to a positive, I'm going to need a positive number and a positive number, or a negative number and a negative number. So always keep those hints in mind. All right, well, guys, since I can only put numbers here and here that multiply to 8, give yourself some options. What numbers do you know multiply to 8? 1 and 8, 2 and 4. So luckily, it's not going to be a lot of things that we have to guess and check. All right, so I tend to check the 2 and the 4. To me, they seem like more popular factors of 8, so I tend to check them first. I want to do it wrong on purpose, so you can see how guessing and checking is going to come into play. So let's say I put a 4 here first and a 2 there, right? Because I know that multiplies to 8. What do my rainbows say now? 4 times x is 4x. 5x times 2 is 10x. Guys, are a 4x and a 10x ever going to go to a 22x? No. But before you say that the 2 and the 4 don't work, switch them. Try the 2 here and the 4 there before you say it doesn't work. Because this 5 is going to make a difference now where things are put. Here, it didn't matter where the 2 and the 5 went. But here, it might matter. So before we say 2 and 4 don't work, let's test them. Let's switch them. Let's put the 4 here and the 2 there. All right, so now 2 times x is 2x. 5x times 4 is 20x. Now, can 2x and 20x get me the 22x's that I need? Yeah, it looks like they can. Let's make sure our signs can work. What kind of signs am I going to need to multiply to that positive number and still add up to that positive 22? I'm going to need a plus and a plus. So that means he's going to need a plus and he's going to need a plus. And then that should work. Let's check. I think this is the best 10 seconds you can take. Does 5x times x get you 5x squared? Yes. Does positive 2 times positive 4 get you positive 8? Yes. Do my rainbows, positive 2x and positive 20x, add up to the 22x's in the middle? Yeah. Now you know you're right. Okay? All right, guys, how did that one feel? Because if they're going to put a number here, we're going to guess and check a little bit harder. Is everybody all right? Yeah? Okay, let's try another one. Okay? All right, our job is to factor this expression first. Break it up into two pieces that will multiply to equal it. Well, first we look for a GCF. Does an x squared, a 2x, and a 24 have anything in common? No, they don't, because 1, 2, and 24's greatest common factor is 1, and 1 doesn't really count. And then x squared, x, and no x, they don't all have a variable, so there's no GCF. So since there's no GCF, that means we're just ready to factor it right now. Let's start breaking it up into two pieces that multiply to equal it. All right, well, according to FOIL, I know whatever I put here and here have to multiply to x squared. Well, guys, who do we need to get that x squared? We're always going to use x and x. So now we're back to, it shouldn't matter where the numbers go now, because it's not like one of these x's has a number in front of it like that 5 did, okay? All right, now I know whatever number I put here and whatever number I put here, it's got to multiply to negative 24. Time out. The only way you can get two numbers to multiply to a negative is if one is positive and one is negative. So I know one of these factors has to be a plus and one of these factors has to be a minus. So keep that in mind because that'll affect your rainbows. When something is positive and negative, they really have to kind of subtract to that middle number now. All right, let's give ourselves options. What numbers could I put here that I know multiply to 24? I know 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Sorry, I second guessed myself there. All right, so again, this is the guessing and checking part. Maybe I check the 4 and the 6 first. Maybe somebody else checks the 3 and the 8 first. It's literally a guessing and checking. So knowing that there's no number in front of these x's and knowing it shouldn't matter where those numbers goes and that I'm trying to get to 24 and then that -2, I kind of like the 4 and the 6 because I know that they could get me a 2 in some way, shape, or form, where 3 and 8 and 2 and 12 and 1 and 24 can't. So I'm going to try the 4 and the 6 first. In any order, it should not matter because there's no number with any of those x's. All right, well, guys, signs, right? I know 4 times x is 4x, x times x, 6 is 6x. How could I get a 4x and a 6x to get me a -2 when one of these has to be positive and one of these has to be negative, right? Because that's the only way we'll multiply to a negative. Well, guys, if you said, all right, well, let's make this negative and this positive. What do a -4x and a 6x add up to? Positive 2x. So it couldn't be that. Maybe the other way. What if I make this one positive and this one negative? What do 4x and -6 add up to? -2. That looks like the winning combination. I need to make a positive 4x, so I need a positive 4, and I need to make a -6x, so I need a -6. And now this should work. Let's check it. Does x times x get me x squared? Yes. Does positive 4 times -6 get me -24? Yes. Do positive 4x's and -6x's add up to that -2x in the middle? Yes, they do. Everything works. So guys, this was the first time we saw negative numbers come into play. So just remember, if your multiplying number is negative, then you're going to need one of these to be positive and one of these to be negative. And that's going to affect how you get that middle term. Is everybody okay with that? Everybody's good still? All right, let's keep it rolling. Let's see if we can do one more before the bell cuts us off. All right, if we factor this, right? First, we're going to look for a GCF. Does an x squared, a 13x, and a 12 have anything in common? No, they don't. So that means I can factor it right now. So let's start breaking it up into two pieces that will multiply to equal it. All right, whatever I put here and whatever I put here better get me that x squared. Well, what did we say is going to do that? And 1x and a 1x. Which is good because it doesn't have a number with one of them. It should not matter what numbers I put in what order here. Okay, now I know whatever number I put there and whatever number I put there better multiply to a positive 12. So again, we're multiplying to a positive. So now I know my signs have to be the same. Positive, positive, negative, negative. All right, let's give ourselves some options. What numbers could I put here that I know will multiply to 12? 1 and 12, 2 and 6, 3 and 4. Okay, now I know I'm trying to get to that 13. So guys, this is the guessing and checking in part. So let's say I'm like, all right, I'll try the 3 and the 4 first. Right? All right, so 3 times x is 3x. X times 4 is 4x. Are 3x's and 4x ever going to, in any way, shape, or form, combine to -13? No. So it ain't 3 and 4. And again, I don't have to switch them because these are both x's. All right, so they're out. Let's try the 2 and the 6. 2 there, 6 there. 2 times x is 2x. X times 6 is 6x. Are a 2x and a 6x in any way, shape, or form ever going to get me a 13? No. So it ain't 2 and 6. Which then leaves the only other option, 1 and 12. All right, 1 times x is 1x. And again, if somebody put 12 here and 1 there, you're perfectly fine. It's still going to work. All right, and then x times 12 is 12x. Now, could a 1x and a 12x get me those -13? Yeah, they could. What signs do I need? To multiply to that positive 12, but then add up to that -13? They both have to be negative. All right, so I'm going to need a -1 and I'm going to need a negative 12 to get everything to do their job. Let's double check. Does x times x get me x squared? Yes. Does negative 1 times negative 12 multiply to positive 12? Yes. Do my rainbows, negative 1x and negative 12x's, add up to negative 13x's in the middle? Yes, they do. Okay? All right. Guys, how do we feel? Give me a thumbs up if you're like, I'm okay. All right. All right, so like I said, if you were to go later on and Google and try and get help, maybe even from a brother or a sister or a friend or an adult, maybe they didn't learn to factor this way. There's other ways to factor. This is how I like to teach you. All right, and if it's not working in a few days and you want me to try a different method with you, I am perfectly happy to show you a different way once we have tried this. If we could factor this way, I'd be happy. Because like I said, I do really feel that this is the way students remember how to factor months and months from now, because everything has a job to do, okay? All right, you have a homework on Delta Math. It's 8 questions, okay? I would like you to try it. Let me just double check the attendance and let you guys get out of here.